So we had a customer ask about doing raised panel doors out of MDF on our Stepcraft machines, and I've done some research online. I was looking, there really isn't a lot of simple ways to do it. You can use a program like Aspire or a molding toolpath and do a 3D carving with ball nose end mill, which takes a lot of time, but you can get a raised panel effect from that. If you had a bigger, more high-end machine, you can get into the custom shaper bits that will give you the profiles you need in more of a production environment. I wanted to come up with something that could use basic end mills that you may have lying around, including a down cut compression end mill and some sort of a V-bit. In this case, I'm going to be demoing this with a 110 degree V-bit, which you can also get in 90 or 60, or I believe up to 120 in 1/4 inch shank, and you can go up to like 140 I've seen in 1/2 inch shank. So there's a lot of options there, but I'll explain. So this is what I came up with. I came up with what I think is a pretty simple way to do it. And let's start with our first panel. So what we're going to do is set our job size to 18 inches wide by 24 inches tall, 3/4 inch piece of MDF we're going to be using. The first thing we need to do is create a vector that is the size of the door itself. So 18 by 24, and we're going to anchor it to the lower left corner at position 0, 0. So when we click create, it looks like nothing happened, but there is in fact a vector all the way around on that. The next thing we need to do is we need to bring in and create a profile for the top part of the raised panel door, so the outside top surface area. And the easiest way to do that is select the outside vector, go to offset and layout, go inwards, and we're going to go inwards on this 2.25 inches. We want to make sure create sharp offset corners is selected, and we'll select new. And you can see we have our next vector. The next thing we need is another vector that would represent the top of the center of the raised panel. So we're going to do the same thing. We're just going to offset inward again, the 2.25 inches, and there's our inside raised panel. So we've got that. Now we need to determine how deep we want this, the floor of the pocket around the raised panel to be. And in this particular case, we are going to do 3.25 inches. That's how deep we're going to go down in this area. So we need to create 2 more vectors, and in order to do that, we've got to get a calculated number first. So what we're going to do is click the line tool. We're going to go out here in the gray area. We're just going to draw a line. Then we want to select that line, Control C, and then Control V to copy and paste it. I'm going to come here to Move Selected Objects and make sure I'm on Relative. And we're going to move the second line down, so negative 0.325, which is the depth of this pocket. So I'm going to zoom in here. If you're looking at this, this is kind of like the top surface area of the door, and this is the bottom area of the pocket. So it's like you're looking at it from the edge. We need to know what angle V-bit you're going to be using. In this case, I'm going to be using a 110 degree V-bit. So I want to make sure that these 2 snapping buttons are selected in Vectric. And I'm going to select the line tool, and it'll snap automatically to the edge of this top line. So all I want to do is click the mouse button once, and then I want to come over here to angle. Now I'm using a 110 degree V-bit, which if you divide that in half is 55 degrees. Subtract that from 90, and that's going to give you 35 degrees. So I want to make sure that we have a negative sign because I want the angled line to go in this direction. So we're going to do an angle of negative 35 degrees, and we're going to give it a length of, let's just say 0.75, and click enter, and you'll see here's my line. So I can click close, and all I need here, this represents the profile of the beveled edge on both sides of the raised panel section of the door. But what I need is I need the dimension. So I'm going to click the dimension tool, the measuring tool. I need from this point on the end of the line to this point on the intersection where the two lines cross. And I get over here a distance of 0.4641. So you're going to want to write that down. I'm going to go back to the main drawing I have here. We're going to select the innermost rectangle. And we're going to go to the offset and layout again, except this time we're going to go outwards. And we want to change that to the 0.4641 dimension that we just measured. Again, make sure these top and bottom check marks are there. We're going to click offset. And I got one final vector that we need to create. And we're going to keep everything the same outward, but we're going to change this to 0.5 inches, and we're going to create one more vector. And I'll explain what all these are in a few minutes. Next thing we need to do is select the innermost rectangle, and we want to Control C to copy it. And then we want to hit the letter N for node editing on your keyboard. And you'll see you've got 4 black squares that appear in the corners. We want to hover over each of the squares and hit the letter C as in Charlie. So we're going to do each one, and what we're doing is we're basically cutting this rectangle apart into 4 separate vectors, 4 separate straight lines. If I hit the escape key, I'll go back to a normal arrow, and you can see if I select each one of these, there are separate lines now. So I want to select the bottom line, hold the shift key, select the top line, and I'm going to come over to under transform objects, set selected object size. I want to make sure that I've selected the center for the anchoring. And what we're going to do here, make sure link XY is not checked. And we're going to add 1 inch to each of the numbers here. So it's 9 right now, so we're going to make that 10, and we're going to click apply. And you'll see that line now is made longer on the top and bottom. Now we're going to select the 2 vertical lines, and we're going to take 15 and make it 16, and we're going to click apply. Now I've got everything that I need. The last step is, remember before we selected that inner rectangle and we hit Control C to copy it. Now we're going to hit Control V and we're going to paste it back. So there's that rectangle vector. So now we have 4 lines in the middle, but we also have a solid rectangle vector there. And that's pretty much all we need for the vectors to create this door. Now we're going to go to Toolpaths. And under Toolpaths, we're going to pin that so it doesn't keep floating away from us. And the very first toolpath we're going to do is the V-Carve toolpath. Now, what I want to do is make sure where start depth is 0, it's the top of the material. Second thing we're going to do is check flat depth, and we're going to change this to 0.325. And that's the depth that that pocket's going to be. It's also the distance between these 2 lines. We're going to select the V-bit. I've got a bunch in my library here, but for this, we're going to use 110 degree V-bit. And then we're just going to click calculate. Oh, we have to select the vectors first. So we're going to select this vector here. Okay, so the first one that we offset, that is the same as the distance between these 2 lines, the 0.4641 line. And we're going to hold the shift key and we're going to select this vector. And click calculate. Now it's going to create 2 toolpaths because, and I don't know if I mentioned that actually, we want to make sure we use clearance tool and select a 1/4 inch downcut end mill. You could go 3/8 or 1/2 inch, whatever, depending on your machine, but you want to make sure it's a downcut because we're doing a pocket there. And we want to have a nice clean edge and a clean bottom face. So that's going to create 2 toolpaths. So the first toolpath is going to be a pocket. So I'm going to go to preview that toolpath. And you're going to see it created a pocket down to 0.325 and then 2 steps on either side. And basically what this is doing is removing the bulk of the material so that the V-Carve bit does not have to do as much work. Then we're going to go and select the V-Carve and we're going to preview that toolpath. Now you can see what happened here. It created a bevel on the inside, but I'm not concerned about that because we're going to create the final one in a minute. But what more importantly, it created the bevel on the outside. And if you look at the bevel, you get this nice sharp angled corner that goes all the way to a point right here. You can't get that if you're using a ball nose and doing a carving toolpath for MDF raised panel doors, because your bit is round. You'll never get a perfectly sharp corner. The only way to do it in this situation is with a V-bit and using a V-carve toolpath. All right, so that's the first step. Now the next thing we're gonna do is go back to 2D view, and we want to go in to create a profile toolpath. We're gonna select the same 110 degree bit that we had for the first one. Our cut depth is gonna be also 0.325. We wanna cut outside the line, outside the vector. And now what we need to do is select the 4 lines that are in the middle, so that we extended the length of before. So 1, 2, 3, and then we'll select this one. And we're gonna click calculate. It's gonna give you a warning. It's basically just saying you're not using a closed vector, you're doing lines. Just click OK. Now, looking at this from the top, what we want to see is each of these 4 lines should be right on the edge of this top raised panel rectangle. And it'll look just like this. But these 3 are not on the edge, they're moved in. And what happens is Vectric will determine the cut direction, or which side of the line it's going to cut on, based on where the start point is for that particular vector. So if you hit N for node editing, you'll see that each of these lines has a green square and then a black square. The green square is the starting line, or the starting point, and then the black is where it ends. So this one is okay on this side. Here's the line that we want to run the V-bit against, and here's where the toolpath is going in this direction outside the line. But as you notice on this one, this vertical one, and this one, the toolpath is on the inside of the line. So all we need to do is hover over the black square on this top line, right click, and click Make Start Point. And you'll see that the green square moved from the left side to the right side. Now the shortcut for that is the letter P, as in Paul. So if you go down to this black square and hover over it, hit P, and then this one and hit P, then go back to this toolpath and simply double click it and recalculate. Okay, and now we're looking at it and we still have a error, and I'm not sure what we did here. Oh, I think I know what we did. I didn't select the actual vector, I selected the toolpath. So what we're gonna do is on this one, we're gonna hit P, and the other one was the bottom one. So this line right here, we're gonna hit P and then calculate. And now we've got it. So now all 4 lines are on the edge of that rectangle, okay? So we can preview that toolpath now, and you'll see what it did. It created the bevel all the way around the raised panel, and you'll notice, just like on the outside, we've got a nice sharp angle on the inside here, and that looks good. Now the only thing we got to deal with now is this piece of material in the middle. It looks like a pyramid. That's got to be removed, okay? And that's just what was left over from this toolpath and this toolpath. So we're gonna get rid of that. And the easiest way to do that is to go to a pocket toolpath. We're gonna select a 1/4 inch down cut with a cut depth of 0.325. Again, everything is based on the depth of that pocket. Now what we need to do is we need to select this vector, okay, which is the one that we moved out from this dimension over here. Hold the shift key and select this one, which is the one we moved a 1/2 inch away from the previous. And we're gonna do pocket toolpath. I must have clicked away from it, 0.325, and click calculate. Now we're just gonna preview that, and you'll notice that entire extra material that was left over disappears. And what you're left with is a very nice raised panel door with sharp corners on the inside and the outside, and a nice clean flat bottom on it. Now, the only other thing you might want to do to this is maybe put some sort of a chamfer or radius around the outside edge. You can do that with a radius tool and a profile bit. For this purpose, let's just do a chamfer. We'll use the 110-degree V-bit. We're just going to go down 1/8 of an inch, and we're going to click that outside most vector and make sure we are on the line. And click calculate. And if I click preview, you'll see it put a nice chamfer all the way around the edge of the door. And there you have it. You have a finished door panel. Now, a couple things to keep in mind. Depending on the depth that you make this channel may determine it will change the distance from this inner vector to this vector. And it will also require you to make these lines longer, and the distance from this vector to this vector will have to be increased. All right, so what we're going to do is let's create a new file, and we're going to use some different dimensions here. So I'm not going to save that. Let's make the new one 16 by 25. So that's the door size that we're using here. Click OK. So we're going to click the first vector. I'm going to move a little faster on this one, 16 by 25. Now I have my vector there. We're going to offset it. Our first offset this time will be 2 inches inward. So that's going to be the flat spot on the outside of the door. I'm going to leave it 2 inches. Our second vector is going to be 2.5 inches. And click offset. All right, so there's the vectors that we have. Now, we got to do the same thing with the line. So we're going to go and draw a line. We're going to copy that line and then paste it. We're going to come over here and we're going to move that line relatively. This time, instead of 0.325 pocket depth, let's go 1/2 inch. So we're going to go minus 0.5, hit apply. Now, we're going to zoom in here to take a look at this. So this is the top surface of our door. This is the bottom of that pocket. It's a 1/2 inch. We're going to click the line tool. We're going to do the same thing. We're going to click on this corner. So we start a line. We're going to come over here. I'm using the same 110-degree V-bit. So I'm still going to do minus 35. This time, because if I did 0.75 here, you'll see it doesn't quite make it down to the bottom line. So we'll just put 1 inch. And now you see that we've gone right past it, which is good. So we're going to go to the measure tool. We're going to measure from this outside point to the intersection again. And let's see, let's do this one more time. I want to make sure I'm accurate on that. So from here to this intersection is 0.7141 inches. Okay, so we're going to write that number down. We're going to need that. We're going to select this vector. We're going to Control C to copy it so that it's in memory. We're going to go over to offset. We're going to offset outward 0.7141 inches. Click offset. Now we'll do another offset at 0.5 inches like we did on the first door, and I'll show you what that does and how to fix it if you see this happen. So we'll click offset again. So now we're 0.7141 and then 0.5. All right. Now we're going to go over and select the inner rectangle and hit N for node editing again. We're going to do the same thing. We're going to hit the letter C, and we're going to cut each of the 4 corners. So we have 4 individual lines. Let's see, we're going to hit escape to get the arrow key, select the top and bottom lines, go over to set selected object size, add 1 inch to this, so it's 8, click apply, select the left and right, and we're going to add 1 inch and go to 17, click apply. So now I have all my vectors. The only thing I need to do is just remember to hit Control V to paste back in that rectangle that was in the middle, okay? Now I'm going to show you, this is not going to come out perfect, and I'm going to show you because I want you to understand how to correct it if this does happen to you, depending on the size that you're doing. So we're going to do the same toolpath. So we're going to go V-carving toolpath. We're going to do 0.5 inches this time for a flat depth. same end mill, same 1/4 inch clearance tool, and we are going to select this vector here and this one, the one that we moved in 0.7141. Click calculate, and we're going to preview those. And you can see I've got a nice clean outside bevel all the way around. Looks good. Now, the reason we do the second toolpath for the V, where we do the profile with those lines that are chopped up, is see what happens when you V-carve the inside of a rectangle. It rounds out the corner, and that's not what we want. We want a square corner. So by creating 4 separate lines and profiling each one of those individually creates a V line in each direction, and then when they crisscross in the corner, you get a nice sharp bevel, okay? So the next thing we're going to do is go to profile toolpath. We are going to select, we have the 110 degree, we're going to go down 0.5 inches on this one again. We're going to go outside the line and then select these 4 inner lines, and we're going to click calculate. Same thing is going to happen. We want to make sure all 4 of these lines are on the outside edge of this rectangle. So these 3 are not, so we have to correct that. So we're going to hit the letter N for node editing, and we need to move the start point to the opposite end. So we're going to hit the letter P here, here, and here. No. Let's see. Did I do this wrong? Let's see here. Okay. Now we'll just recalculate this and see if I messed it up or not. Yep, I messed up the bottom. So we'll go back in and we'll fix that. So we're going to click N again, and we're going to do P. There you go. Now all 4 are on that edge. Everything looks good. We're going to go ahead and preview selected toolpath. And I can already see there's going to be a problem in the corners. All right, so we won't address it yet. We're going to go ahead and we're going to remove this material now. So we are going to select this vector and this vector, and we're going to do a profile toolpath. I'm sorry, a pocket toolpath. We're going to go down 0.5 inches and click calculate. And we're going to preview select the toolpath. Okay, so there's a couple problems that happened here. And this is where I said you may have to vary the dimensions that you use. First of all, on this pocket toolpath, it did not remove all of the material. And that's because we're going deeper now. So the angles change, and all we needed to do really is just move that vector from a 1/2 inch. We should have moved it out probably 3/4 of an inch, and I think it would be better. So what we'll do to fix that is we'll select this vector. We'll just delete it. We'll go back to this one and we'll offset outwards, but instead of 0.5, let's do 0.75 and click off. Okay, and then we'll just select the inner vector. So these 2 are selected and click calculate. Now when we run that toolpath, you can see it's nice and clean, got rid of everything. But now the other problem is in the corners. See how there's this little nub here on each corner? That's there because the lines that we're running the V-bit on need to be longer. And the V-bit just stopped just shy of the edge, and that's what's causing that. So to fix that problem, all we need to do is same thing we did before. We'll go back and select the top and bottom vectors. So we're going to select this line and this line. Now the reason I'm clicking out here is if I click in the middle, it's going to select that rectangle that was living in there. So we only need the lines. So if I select that, hold shift, go to change object size. Instead of 8 inches, let's make that 8.5 inches. So instead of making it 1 inch bigger, we're going to go 1.5 inches bigger. Click apply, and then we'll select this one and this one. And instead of 17, we're going to go 17.5. So all we're doing is on each of these lines, we're making them 1.5 inches, 1.5 inches longer than they were previously instead of 1 inch. Okay, so we'll go to the profile toolpath again, It already has those 4 lines selected. Click calculate. And now you'll see when we preview that toolpath, the corners are perfect. That goes away. So you just extended the line where that V-bit was going. And now you can see we have a really cool raised panel door. The pocket depth is 1/2 inch now instead of 0.325. Same bevels on each side, and we changed the width of this part and this part of the door. So as you see, no matter what you do, whether you go with a 90-degree V-bit or something like a 120, you may have to adjust some of those vectors. But the key here is making sure that this vector right here is offset from the raised panel vector by whatever this you find out doing this angle here. That's critical because you want to make sure that that pocket comes in right at the bottom where this intersects the flat part. Otherwise you'll have a weird line, or if you don't go far enough, you'll chop into this angle and it won't look right. So that's basically how you can do a very simple toolpath for a raised panel door on your CNC machine using V-Carve. You don't even need Aspire or V-Carve Pro. So this could be done with desktop as well. And as you can see, really cool looking, and you don't need any real special tooling, just a standard V-bit upcut and a V-bit downcut. And if you're doing a profile on this door, I would recommend using a compression end mill, most likely. You could use a downcut as well around the profile, but to get a better top and bottom finish, compression is usually really good bit to use for that. I will make both of these files available in the link for this video. Any questions, just email us at info@stepcraft.us.